Okay, so this video is going to cover a factoring a trinomial example. So when it comes to factoring, there's a few things that we need to consider first. First thing, do we have a greatest common factor? That should always be our first check when it comes to any factoring problem. Do we have a greatest common factor? So if we have a greatest common factor, that means that we would have something in common with the numbers, the coefficients in each one of our terms, or we would have something in common with the variables in each one of our terms. So here we have a trinomial, which just means we have three terms here. So let's take a look at what we have in common. First off, the first thing that I notice is that there's a negative here in front. And we have a rule that says that the only time that we factor out a negative is when our leading term is negative. So here we do have a negative out in front, so I'm going to go ahead and factor out a negative. Otherwise, comparing our numbers here, we have 3, 3, and 36. So looking at 3, 3, and 36, hopefully this one's a little easy to see that they do have a 3 in common. 3 definitely goes into 3, and 3 definitely goes into 36. So we do have a 3 in common, so we can go ahead and tack that onto our greatest common factor. So far we're pulling out a negative and a common factor of a 3. Now, we need to take a look at our variables next. In order for us to have a greatest common factor with our variables, we need to check two things. First, we need to make sure that each one of our terms has that variable. And then second, we want the lowest exponent out of those. So let's start with looking at our variables here. So I see that we have x's, but we also have some y's thrown in here. So first off, our variable would have to be in common with all of our terms. So for this particular example, we would not be able to use the y. Notice we have a y in the second and the third terms, but we don't have one in the first terms. So that means the y cannot be part of our greatest common factor because it's not in common with all three terms. So that means we're just looking at the x. And we do have an x in each one of these terms. We have an x cubed, an x squared, and an x to the first. So we do have an x in each term. We want the lowest one, which is the x to the first. That is the one that we want to take. So I'm going to tack that on over here. So after looking at our coefficients and our terms, we have a greatest common factor of a negative 3x. Now what we need to do next is we need to divide that out of each one of these terms. Alright, so we figured out that our greatest common factor was a negative 3x. So if we are going to factor out a negative 3x, what we need to do is we need to divide each one of our terms by a negative 3x. And what this is going to do is it's going to allow us to see what are we left over after we pull this negative 3x out of this trinomial. So in order to figure that out, we need to do the division. Now, in order to do the division, we need to know the quotient rule. So remember, the quotient rule applies when we are dividing like bases. So that's going to come in when we're going to be doing the division, the x cubed over x, x squared over x, and so on. Otherwise, we're going to divide the numbers like we normally know how and use the quotient rule for our variables. So go ahead and divide. So here in the front, we have a negative 3 divided by a negative 3, which gives us a positive 1. Using the quotient rule on our variables there, x cubed over x, quotient rule tells us to subtract exponents. So 3 minus 1 leaves us with x squared. And remember, we had that 1 in front, but we don't have to write the 1. It's understood to be there. Moving on to the next term, we have a negative over a negative, which is positive. We also have a 3 over 3, which is going to cancel out to a 1. Using the quotient rule, we have x squared over x. So again, quotient rule tells us to subtract. 2 minus a 1 gives us a 1. Also notice we do have this y sitting over here. So we don't have a y to divide out. That just means we are dropping that y down. Moving on to our final term, we have a positive over a negative, which gives us a negative. And dividing our numbers out, we have 36 divided by 3, which is a 12. And using the quotient rule on our variables, here we have x over x, which cancels out. Or using the quotient rule, that would give us a 1 minus a 1, which is a 0. So that x does go away. But we still have that y squared sitting up there, so we do need to drop that down with our problem. So after factoring out that negative 3x, we're left with an x squared plus xy minus 12y squared. Now we're not done yet. What we need to do at this point, now that we have factored out our greatest common factor, we need to take a look at our remaining polynomial and see, can we factor that? Okay, so factoring the trinomial, what we're going to do, since we're working with a trinomial that has a leading coefficient of a 1, that tells us that we are going to use reverse FOIL. So I'm just going to drop down this negative 3x. I'm going to draw my parentheses, and let's go ahead and start factoring. So the FOIL method, remember, tells us the order in which to multiply a polynomial. Now this f stands for first, and what that tells us is the first terms out of each one of these binomials need to multiply to get the first term in our trinomial here. So we have an x squared, which means we need to think what times what is going to give us an x squared. And the only possible way to get x squared is an x times an x. Then, after we figured out that first one, we move our attention to the last term. And that last term comes from this L here in the FOIL method. L stands for last, which tells us the last term in each one of these binomials multiply to get the last term in this trinomial. So here we have a negative 12y squared. So the easiest thing to take care of for this one here is the variable first, the y squared. The only possible way to get a y squared is a y times a y. Now, we also need to figure out how to get that negative 12. So let's figure out how to get the 12 first. So in order to figure out how to get 12, well, what gives us 12 when we multiply? Let's list all those different possibilities. So in order to get 12, a 1 times a 12 would work, a 2 times a 6, or a 3 times a 4. What we're looking for is we want the combination that multiplies to get our last term, but adds or subtracts to get this middle term here, this middle coefficient. Our middle coefficient is 1. So out of these three combinations of factors, which one would add or subtract to get a 1? So 12 plus 1 or 12 minus 1, 6 plus 2 or 6 minus 2, 4 plus 3 or the 4 minus 3. And it would have to be the 4 and the 3 because 4 minus 3 is a 1. And that's exactly what we have here as our middle term. So we're going to use the 3 and the 4. And it doesn't matter where you put the 3, where you put the 4, just input them in. What's going to matter is the signs that you put in front of those numbers. To figure out what signs are going to go into here, the easiest thing to start with is this rule here that says whatever sign our middle term has, the bigger number needs to have that. So let's take a look at our middle term, a 1xy. Now that one is positive. So since our middle term is positive, the bigger number out of 3 and 4, which is the 4, has to have a positive then. So because our middle term is a plus, that plus must go with the 4. Which means the only thing we need to figure out is, do we have a minus or do we have a plus in front of this 3y? So then let's just think about this for a second. Remember that this negative 12y comes from multiplying the last terms together. So would a positive 3 times a positive 4 give us a negative 12? Or would a negative 3 times a positive 4 give us a negative 12? Now, remember, different signs in multiplying gives us a negative answer. So here we would have to have different signs. And since the plus is with the 4, the minus has to go with the 3 to give us different signs here. And there is that quick little check that we can do. Remember that these must multiply to get the last, but add to get the middle. So negative 3 times positive 4 is a negative 12. And negative 3 plus 4 is a positive 1. So our signs are correct here. So our final answer here is a negative 3x times x minus 3y times x plus 4y.